Thakur, without further ado, asking about the importance of maintenance in an industry like yours. How crucial is it for your business or your business lines?
And in my mind, the pandemic has hastened the whole technology explosion which we have experienced over last let's call that 7 to 8 years. And I feel that this is I'm a technology guy, 25 years on this space, and I have seen how technology is impacting business and human behavior. But I see a fundamental shift over the last 6-7 years, and that fundamental shift is that human beings have changed. My paradigm thought on this digital, what we call as digital, is that there is a fundamental shift in human behavior. Human beings have changed. They are far more impatient. They are far more decisive. And if human beings have changed, it cuts across everything. It cuts across a customer. It impacts an employee. It impacts a maintenance man. It impacts an investor. Whatever hat a human being wears, it impacts. And in that context, it impacts maintenance also, because fundamentally his behavior on the floor has changed. So that's one aspect of it. And as Pankaj was saying, that last 1.5 years, because of forces which are making people work and manage the work remotely, and naturally maintenance also has taken a new dimension. Now, in context of the business which we run, we are a cement business. We are world's largest as far as our global footprint is concerned. In India, we are number 2. We would have factories pan-India across, and it's asset heavy, it's capital intensive. And when we say that the cement business is capital intensive, it becomes important that we sweat our assets. Giving you a feel that Indian business would be running somewhere between Indian businesses, 87 to 93% of throughput Indian businesses would be operating at. And some reports from McKinsey says that if assets are sweated properly, they can go up to 120% of the throughput. So it's mind-boggling. So from 90% to 130, 120%, it's a sheer 30% of jump which we are talking about. And being, if we take a lot of humility and we say that even if we capture 1/4 or 1/5 of that, the value unlocking for a 65 million ton cement business, you can appreciate how important it is. It would be. So that's it's the era of manufacturing. I think it's an era of heavy capital intensive manufacturing where value unlocking is possible. And I'm not saying that this entire value unlocking will only happen through maintenance, but the maintenance cost, if you look at in a cement business, it wouldn't be more than 2 to 2.53% of your total revenue cost. There are far much larger cost elements. That's not the point. So maintenance costs you have, maybe you would be able to optimize to some extent, some X percentage out of that, and you can see the bottom line impact. But the larger cost is, the larger opportunity is sweating the asset and deriving throughput out of that. That's a tremendous opportunity. And that's where our mind is, Pankaj, that how do we unlock that hidden potential from manufacturing? I mean, you just think of numbers. If you want to put up a 1 million ton cement plant, what sort of cost it would be? And if you merely unlock 67.5% of 60 million, what sort of value opportunity? I'm not giving you a number, I'm just giving you the feel of the opportunity which this business has. So it has large opportunity, Pankaj. It has substantial opportunity to unlock.
Well, truly speaking, Vinit, I think you're talking about some very, very large, staggering numbers which can impact the manufacturing and setting up this very capital-heavy, intensive industry. Also, given setting up something like a cement manufacturing plant has a large-scale supply chain all across. How does new age technologies like IoT and data generated from all these sensors all across play a very pivotal decision-making role for operations on the ground?
And so data being there, we've been hearing about PLCs, we've been talking DCS, we've been talking SCADA system, we're talking high-level controls, we've been all talking about that. So data has been there, all prevalent, and if I go back to my experience around 7-8 days back, I sort of correlated the way IT transformed itself from distributed data center to centralized data centers. This was sort of a visualization some 8 years back when I was in Dalmia's, probably. The same way manufacturing will transform itself, because I always felt there are similarities into the instrumentation rooms of large manufacturing factories and data center, erstwhile data centers of, so it was about to happen, Only difference was it turns out huge amount of data, that's one. And two, these OT, let's call that, let me give it a name, operational technology data. This OT data has been very religious, because it has a direct impact on production. So nobody wanted to touch it, play around it with it. So it was always a secure environment, and that also kept it isolated. That also kept the whole data isolated. So I saw some very nice talk on data strategy, data life cycle, how to use DCS data. So I'm just trying to bring all those thoughts together. That data, one is I consider these all sensors scattered for last 30 years. In my humble and limited knowledge, I call them IoT. All of them are IoT capable. So this has been there. IoT has been there for decades now in the ecosystem. That's what I call. So that's bullet one. Data has been there. What was not there was this data was isolated and it was in remote locations. So that was the challenge. Now, so one challenge was to bring out that data at IT layer. That a lot of you will be talking about OT to IT and the OPC protocols. Bit of technology, sorry, I'm bringing in, by which you bring up the data at the IT layer. What we've been able to achieve is that fundamental shift. Our data for the large organization, our data is at IT layer. Now, the entire data we have brought. Again, a bit of business context. If you look at a cement business, it has 4 large. Is the mining, where you have large mines scattered across. 1, 2, you have raw meal preparation area where you crush the material. So that's a crusher area and raw meal preparation area. That's second stage. Third is the entire pyro process, where you actually do the chemical processing of the raw material in a equipment called kiln. So that's a pyro process, and then you have your blending process, where you blend other additives to make and grind clinker to make cement. So these are the 4 critical business shops, or rather plant shops, you can say, in the cement manufacturing value chain. So when I said data, we have been able to bring it up to the IT layer. What I meant was data of the last 3 mining data. Still, we have not been able to bring it up to the IT layer. Now we can name it data lake or whatever jargon we want to, but the key message is now we are able to bring that data. So that's one component of large data. Other component of data which has been always there, but again disconnected, is the entire business process which runs on our backend ERP. So that's where the SAP plant maintenance or Oracle, I'm forgetting the name of module, but let's assume Oracle maintenance module comes in, or for that matter any backend ERP. That's crucial. That's not been in anywhere. So all the actuals so far have been going into all these ERPs where the actuals were never there. So it is important that now actuals get into your ERPs, and then you have an actual feel of the cost of whatever you do, be it maintenance cost, be it operation. So that's the other component data. Then there are a lot of, again, I heard some people talking about, that when you're walking around, you can capture data. We're doing that. We have mobile applications whereby we give the data to we give the application to the people and their condition monitoring schedule, and the schedules are maintained there, which they can fill up and then bring it back. So that's the, we call that walk by inspection, walk by inspection, WBI, So we capture that data. So that's the third. And of course, all the advanced sensors, the condition monitoring sensors, which we are talking about, a lot of people have been talking about, we bring that. So the key message was to create a data ecosystem, have a data strategy. I'm forgetting the name of the lady who was talking about, Sandhya, maybe the ma'am, probably Sandhya ma'am you're talking about. So that's the data strategy which we worked upon, and that the data strategy was conceptualized under, again, somebody was talking about a framework, we call that cement industry frameworks, we call that CIF framework. So based on that framework, we created this data strategy, and now that is executed and now it's there. So that's one. Now, so you have data, what you can do with it. So what you can do with it, and mind you, this data is quality data. So, and again, this data is nothing but the behavior and the characteristics of your assets. So that's another way to think about this data. So there are 2-3 ways. So with your data, get into operational analytics, you get into descriptive analytics, all that, you can raise the alert, you can go back to SAP, you can raise maintenance orders. So all that you can do that. So that becomes the that becomes the descriptive analytics. But the other component is equally important, where you can get into predictive component of it, and which has a equally, if not a larger value. And why am I saying equally, if not larger? Because somebody was talking, and I agree with him, that even on manufacturing companies, even working on operational dashboard has been a challenge, And right now we are straightway leaping into digital world, digital twins, and predictive analytics. So both the components are equally important, operational aspects and this aspect. So the message here is that you need to have a data strategy, you need to have a data ecosystem, you need to capture data from as many places as possible. You need to build your operational stack on that, and you need to build your advanced analytics on that.
My next question, the success stories might be under you. On specifically on advanced manufacturing analytics pertaining to maintenance, possibly asset lifecycle management. With the plant size of yours on multiple locations, there must be a very good data strategy, but also getting this quality data into actionable insights. Is there something which you would like to share, sir?
So on advanced analytics, our success initially didn't come through maintenance. Our success came through the process component, process prediction and quality prediction. That's where we created our success. So I was talking about cement mill. I'll talk a bit about it and then I'll come back. I'll go a bit away from maintenance to advanced analytics on cement quality. So we call that, so I'm not getting into specifics. I'm not too sure how much I can open up, but the message here is that we are able to predict cement quality at least 60 minutes in advance. And when we are doing that, what it helps us is unlocking and optimizing the energy cost. 3 things. The energy cost, one, the uniform variability of quality, okay, and the beauties. It is unleashing the throughput of the mill itself. So if I give you some numbers, it is easily unleashing around between 2 to 5% of the throughput of the mill. It is unleashing around 2% of energy cost, and variability. I don't remember the numbers, so variability. Now that's the success story, which is the first success story which we created for ourselves, and based on that we realized advanced analytics is here now. You can do something, and then we got into doing the downtime analysis of the entire factory, identifying the critical assets which are giving the maximum downtime. And now we have a series of advanced analytics projects going on. If I can give you some names and if it helps, we have advanced analytics work going on vertical roller mill. We have advanced analytics work going on our kiln. We have advanced analytics work going on ball mill. We have advanced analytics work going on bucket elevator. So now we have at least a dozen work which is going on in India. Globally, it would be some 30, 40 advanced analytics work streams which we would be talking about. And the key thing, the way we are selecting so first of all, a couple of messages. So you need an advanced analytics infrastructure. That's the key thing. The main thing which you have done is you have brought data to IT layer. You have ensured that the quality of the data is there. So thereby you are establishing quality of the data. That's the most difficult thing, Everything else beyond is technology and orchestration of technology. So in our ecosystem, we have high-level controllers, and we have predictive output from advanced analytics infrastructure, which we call artificial intelligence on edge. I mean, all these are common languages, which in turn takes charge of high-level controllers. Predictive maintenance, some of the areas where we have been able to identify do the use cases is things like VRM failure prediction. It is giving us 90 days of prediction in advance. Preheater blockage, 30 hours in advance we are getting the prediction. Kiln refractory failure, again 3 months predictive advanced intimation we are getting. So quite a few. I mean, we can go on numbers, but the key message is it's here to stay. It generates value, and it's worth spending time on it.